Alright, what's up, multi-sim live users? Today we're going to get going on our 3-bit up counter. It's actually a 1 to 5 counter, but in order to get anything going, at first, what I like to do is to make it so it displays the full count. So what we're going to do is, we got to pop this out somehow. There we go. What we're going to do is come into digital, go into flip-flop, and we're going to use the JK flip-flops here. In order to get the full count, we're going to need 3 of those. So I'm going to copy those so I don't have to go back into the software. I'm going to need a power source. Which is going to be a digital constant here would work. We're going to hook that up to J and K, so they're in their toggle state. And then these appear to be active highs, which we haven't really worked with in class, but we were talking about them the whole time. So if they're activated with highs and we don't want them to be utilized, then we need to hook them to the opposite of a high, which is a low. Just going to assume that their symbol is correct here. I haven't tested it myself, but it is telling me, because there is no inverting bubble, that it is active high. So I'm going to trust the symbol here. Let's see, what else do I have? Great. So that should be good. Now we need a clock. So use this digital clock here. Don't go and use this one. It doesn't work. The clock voltage. You're going to want to use this digital clock right here. Since these are positive edge triggers, and I want an up counter, I need to go to the opposite, not Q. And then you'll need some way to monitor what's going on. So I'm going to put some probes on here. We don't have probes actually, but I'm going to put some LEDs on here. And for that, we're going to rotate them around. And not sure why that connected there, so I'm going to undo that. Let me get that out of the way for now. There we go. Copy that. And copy that. I'm not sure if we have to ground them. I bet we do, just to have the potential difference. I don't think we need resistors, though. I am just going to go ahead and ground this. This isn't my finest circuit. Apologize. In terms of neatness. All right, so we're looking at 1 kilohertz. Let's run it, see what happens here. So it looks like we're getting something. It's a little fast. I'm going to stop it. I got no ground node. Okay. I can deal with that. I'm going to decrease the frequency here to 10 hertz. And then if you look up here, this is milliseconds. So it wouldn't expect to see a full cycle until it gets to 1 second. Seven, 0, 1, 2, 3, 4, 5, 6, 7. Great. So what I'm going to ask you to do then is to modify this. So using a logic gate to create a signal that activates once and only once. And don't forget, these are active highs. So what type of gate, hint, hint, produces a 1 once and only once? And then when do you want it to produce a 1? And what do you want to do with the 1? So maybe you want to reset this flip-flop. Although, maybe you want to preset it. Maybe you want to turn that light on. If you want to turn this light on, hook that 1 to the set. If you want to turn it off, hook it to the reset. All right, so you have some options there. Whichever one you're not using, though, keep it going at 0 here, so it's not in use. And above all else, do not hook the 1 to both inputs. That's going to give it mixed signals. All right. Hang in there. Once you get it working, take a screenshot here and post it. Thank you.